folks. Sorry I'm not there. I hope these notes help. And this way you can hear me talk through things while copying down the notes as well as having the notes available. So we're going to dive right in. So right here, representing two categorical variables and statistics for two categorical variables. Cool. So congratulations, you made it through the first unit. We are through unit 1. We're going to use it constantly still, but we've made it through our first unit. So taking a look at this, we've got a two-way table, meaning we've got something up here and something here. So here's one variable, what class, and here's another variable, survival. So think to yourself, like, what might this be? We've got first, second, third, and crew. We've got a lot of people not surviving. What might this be? If you said the Titanic, ding, ding, ding. Bad day to be on a boat. Okay, so we're going to look at a few different types of information that we can get from a table like this. And frankly, you've done a lot of this in math too already. So keep that in mind. Sweet. So percent of passengers who were first class. I want you to pay attention to the percent of who. So right here, this just says of passengers. That tells me, I'm actually going to match my colors here. That tells me of passengers that I'm talking about the total number of passengers, this 2,201 passengers. So then the percent of those passengers who were first class. And so first class, here's my first class. Here's the total number of first class. This has nothing to do with survival. It's only asking me about the first class passengers out of the total number of passengers. So I can go ahead and set that up. I'm going to say this, and I've got first class passengers. That's 300. I don't like that. Let's make this black. So that's 325 out of the total of 2,201. And when we throw that in the calculator, that gives us 5/2201 gives us 0.1476, so about 14.76%. And remember, for stats, there's not like oh, you have to go to this decimal unless it's very specific with you. Delta math is definitely pickier about that than the AP test. All right, so percent of passengers who were in first class was about 15%. Okay. Now, let's look at the percent of survivors who were in first class. So now we have a new of. This one's of survivors. So that is the group we're looking at. No, excuse me. That is the group we're looking at. And the total number of survivors is right here at 711 because total saved was 711. And then survivors who were in first class. So that I need to look at survivors, just this row, and now just first class. So that both things need to be true. They survived and they were in first class. Okay. Now we make a fraction. So it's survivors who were in first class out of the total number of survivors. And that's going to give us 203 out of 711. When we pop that in our calculators, we don't get a syntax error. We get 0.286. So it's about 28.6%. Starting to feel like maybe first class is overrepresented, but that's okay. Great. Option 3% of first class passengers. So first class passengers is our denominator. So of first class passengers who survived. So once again, we're looking at both survived and first class. And we can make our fraction. So that's going to be survived out of first class. And so there's our 203 that survived out of 325 total. And that is 62.5%. All right. And last but not least, we want to look at the percent of passengers who were in first class and survived. So this and, let me back up. This of passengers is telling us it's out of the total again. So of passengers, that's going to be our denominator, who were in first class and survived. That's this guy, first class and survived. That's our 203. So that's going to go on top. And so we'll get 203 out of 2201. And that gives us about 9%. Okay. I also just want to look at the percent of survivors overall. I'm just going to pop that up here. So overall percent of survivors, percent of passengers who survived, if I want to follow the same pattern. So the percent of passengers who survived, that's going to be our 711 over our total. Okay, so 711, that's the number of passengers who survived out of the total number of passengers. And that is about 32%. All right, so just good thing to have in our back pocket. Okay, so all of these are different things we could look at from a two-way table. This is going to come up again when we get to our probability unit, but big picture. You want to think every time you're dealing with a two-way table, what's my denominator? What is my overall? And what's the piece that I'm comparing? We can do a lot of different things. You just have to keep track of which is which. Now, I'm going to label these A, B, C, and D, because we're going to come back to this in a second. All right, moving right along. So let's think about three different types of frequencies. First one we've got is joint relative frequency. And notice all of these actually have the word relative in them, so let's define that real quick again. So relative means we're relating parts to a whole. So that's going to be largely as a percent. Could be decimals that represent a percent, right? A part of a whole. So relative is always comparison. If it's not relative, it's just the straight up numbers. So for instance, the frequency of first class passengers is 325. The relative frequency of first class passengers is right here. That's about 14%, 15%. So number, percent. That'll come up for question 23 when you're working on your problem set. All right, so joint relative frequency. That's when we have both categories are accounted for. And you're taking this out of the total. So both things are true compared to the whole. Marginal relative frequency, it's about the margins, the things on the side. So that's going to give us information about one of the variables, one of the categories, or the other. So that's going to be one category out of the total. And then conditional relative frequency is going to be when both categories are true. So, first class and survived out of one of the categories. So, given we know this, given we know they're in first class, what's the probability that they also survived? Okay, so take a second, see if you can decide A, B, C, and D where they would fall. Is it, which one of these is joint relative frequency or ones? Which one or ones of these are marginal relative frequency? And which one or ones are conditional? I would encourage you to pause, think about it, talk to your neighbor. Okay, I gave you your chance. It's better for your brain if you think it through. That's normally when I would take attendance. Okay, so joint relative frequency. If you said D, you are correct. Because in D, we have the first class and survived. So we had first class and survived out of the total passengers or the total. I like to think of this number as the total because it's the total overall. Okay, good. Now, marginal relative frequency, one category over the total. Drum roll, please. If you said A, percent of passengers who were first class, you're correct. Notice, this has nothing to do with survival status. So we're just dealing with one category compared to the total. And so that was just first class. Whoa. My handwriting's going nuts. Over the total passengers. Now, for our conditional relative frequency, we have both B and C. I think you figured that out by now. So the key here is this is conditioned on surviving. C is about of the survivors, what percent were in first class. B is conditioned on class. So of the first class passengers who survived. So both of them have the same numerator. Both of them have that both categories numerator. But then the category that we're conditioning on changes. So in B, we had the first class and survived out of first class. Whereas in C, we have the same numerator. We have the same top value. So first class and survived. But now we're comparing that to the total who survived. Okay. Cool. So, why is this important? Well, we're gonna, like I've been say like every class, right? We're gonna do a lot more with this second semester when we get into our inference, but this is the start of it. So when we're comparing categorical variables, we can start to get a sense of, does this affect, right? Does the class you're in on the Titanic affect your chance of survival? If you haven't seen the movie at this point, I don't feel bad spoiling it. It absolutely has an effect on your survival. So let's look at the math behind that. In words, if your conditional relative frequency is approximately equal, and it doesn't have to be perfect, to your marginal relative frequency, then we can say that these are independent. Or you could say there appears to be no association. However, if your conditional relative frequency does not equal or roughly equal your marginal relative frequency, then we say, and this is one of those things where you want to just use this sentence stem, say it the same way every time. You want to say there appears to be an association between whatever the variables in question are. So there appears to be an association. This is one of the things that year after year in the chief reader reports from the AP test that students tend to want to state things more concretely than they really can. So it's okay to be a little qualifying here, a little cagey, right? We don't have to say there is an association. We can just say there appears to be an association. We could be wrong. Everything in here is, well, we could be wrong. So always keep that in mind. Where this comes into play, if we want to see this in action, is let's compare the conditional relative frequency of surviving given first class to the marginal relative frequency of surviving. So what that's going to look like here. I hate this little stray mark there. Okay. So survived given, maybe that brings you back to math 2, first class. And then this is just going to be survived. So survived given first class is right here. We know that they're first class and they survived and were in first class. So that is our 62.5%. Compared to our overall percent who survived. I believe we did that up here. Overall percent of passengers who survived. That was 32.3%. Okay. Now, we'll get into with inference, like, is this actually a significant difference? But I would say these are pretty different percentages. These are pretty different numbers. So this is almost twice as much as this one. So the chance of surviving, knowing that you're a first class passenger, is basically double the chance of surviving overall. I'd say there appears to be an association between being in first class and surviving the Titanic disaster. Okay, good. So, what if we wanted to make a picture of all these things? All right, let's look at side-by-side bar graphs. And given the way that this page is spaced out, I think I'm going to do like side-by-side and then segmented down here. Whoa. And then mosaic plot up here. All right, so side-by-side bar graph. Bar graphs, like all graphs, should have nice labels. They should have reasonable scales. We want to be able to see what's interesting. And so a side-by-side bar graph is a bar graph that has multiple categories. So it's kind of like we're making a bar graph of class for the people were who survived, and then we're making a separate bar graph of the class for people who didn't survive. But then we're putting them right next to each other. The other thing to consider is if we look at the number of first class passengers who survived and the number of third class passengers who survived, those numbers are pretty close. I mean, in the context of 2,200 overall, this is pretty close to 200 and this is pretty close to 200. But that's not really what matters. We want to know relative to all of the first class passengers and relative to all of the third class passengers, right? This 200-ish represents a much smaller portion of the total third class passengers, whereas this 200-ish represents much more than half, about almost 2/3 of the first class passengers. So noting that these are both 200 is not as illustrative, is not as illustrative. It's a good thing we don't use that curriculum in math. It doesn't show us as much as thinking about them compared to the totals. So let's make some bar graphs. For this side-by-side bar graph, I think what I'm going to do is put, do I want to do it by class or survival status? It kind of doesn't matter. Let's do it by class down here. And so we're going to say first, second, third, and crew. And then over here, these are just going to be percents. So I'm going to say that, well, I bet first class has the highest survival rate at 60%. So let's say that this is like 70%. And that this is halfway, so 35%. That'll give us good enough benchmarks. So those are percents. Now, in first class, and we just have this from above, 62% survived. And so I'm going to say, here's first class, and 62%. So maybe something like that survived. Whoa, why does it make triangles? Okay. And I'm going to shade that in. And I'm going to make a little key down here. So this one is going to be survived. Kind of like algebra tiles. Positive is filled in. Empty is negative. Shall we just say died instead of did not survive? We're going to say lost. Let's soften that blow a little bit. Okay, so about 62% survived, which means 38% were lost. So a little bit more than this were lost. Okay. Now we'll do the same thing with second class. So in second class, those numbers work out to about 41% surviving. So not terrible, but definitely not as good as first class. A little bit more. And we're going to shade that in. And if 41% survived, that means that 59% did not survive. So almost as many, almost the same percent as first class who survived. Okay. Now, for third class, only 25% of them survived. So that's like here. I saw Titanic 3 times in the theater with my grandma because she just loved it. And it absolutely freaked me out because I was very much a child. And all those people were just trapped on a boat that sank. Terrifying. All right. And then crew had almost the same metric. So the crew was actually the worst position, 23%. I think there were some like explosions in the boiler rooms. So 77% of them perished. Oof. Great. So what we can really see from this side-by-side bar graph is that the relationship between surviving or not looks very different depending on what class you're in. Especially if we wanted to lump like first and second class together. Again, not a great day for anyone. But compared to third class and crew, very, very different setup. Okay, great. Side-by-side bar graphs. Now, segmented bar graphs. I'm going to do this down here. For this one, I'm actually going to condition this or put my x-axis on survival status. It'll just give me a different picture than this, but sort of similar information. I'm going to say, bloop. I need a little more space than that. Okay, let's change up our colors too. So for a segmented bar graph, this time, just for fun, I'm going to say that this is on survival status. And I'm going to say saved versus lost. For these, we have to go up to 100% because for all the people who were saved, who survived, they were either in first, second, third, or crew, right? They were in one of those classes. Same goes for all the people who were lost. They were in one of those classes, right? That's all the possibilities. So there's our 100%. I'm going to put a mark here for my 50%. And, wow, that was very much not halfway. That's better. Okay, great. The other thing is both of these bars are going to go all the way up to 100%. Oh, boy. What is happening with that? Okay. All right, good enough. We try to make those as even as possible, but we're not robots. That's okay. All right. So within the group that was saved, right? Within the group of survivors, the percent of survivors who were in first class was just under 30%, 28.6. So here's 25. So I'm going to say of the survivors, this was my first class. And then of the survivors again, 118 out of 711 was about 17%. So from about 28%, 17, 45, so like just under 50%. There's your second class. All right. And then for third class, we had 178 out of 711. That's 25% almost bang on. So we're going to say like this. And then the crew had 212. So the crew actually had the most number of survivors. And that was about 30%. When it comes to who was lost, though, like these don't seem so bad. They seem relatively evenly distributed. Then we look at who died. So, of the people who were lost, there were 122 first class passengers out of a total of 1490. Out of 1490. That's just 8%. So if this is 25, this is like 12. So like down here, here's our first class. And then of the people who were lost, that's in second class, that's 167 out of 1490 again. That's 11%. 8 and 11 is 19, so it's going to be like just under 20%. So got second. Then 528 third class passengers perished. So that's 35%. So 20 plus 35, that takes us to a little 50%. So there's our third class, which means the rest of these deaths were crew. So 673 out of 1490, 45% of the crew. No, excuse me. 45% of the people who died were crew members. All right. So, survival status. So, this is a segmented bar graph. The bars are segmented into the categories. And so we have one category on the bottom, and then we segment by the other category. All right. Last but not least, a mosaic plot. This is very, very similar to our segmented bar graph. We're going to switch it up and do class along the bottom again, along our x-axis. But in a mosaic plot, the relative areas also have meaning. So, I'll pull up my... hold please. Okay, so mosaic plot. So here we've got, let's do this in blue. We're going to have a big old square. Beautiful. It's not square at all. Let's try this again. Come on, robot, help me out. Yay! Ah, gotta love our robots. Okay. Just like in our segmented bar graph, it's going to go up to 100%. And similarly, this is more a me thing than anything else. I'm going to put, that's, okay, so there's my 50% and then 75 and 25, just for benchmarks. Now, instead of splitting this into 4 even bars, the width of the bar is going to reflect the relative portion of the total passengers that class represents. So I'm going to put class along the bottom. And so first class ends up being about 14%. Second class passengers represented 13% of the total. Third class passengers represented 32%, about a third. And then the crew represented 41% of the passengers. So when we apply that, the first and second class bars should be sort of the same width, roughly. First is, 1% larger. Third class, if I think about that as like 50%, maybe that's 40%. And maybe even a little bit more like that. Right? This part's kind of an art, not a science. If you had graphing software, of course, make it accurate. If you're drawing a graph by hand, do your best. Okay. So I'm going to use the same key as before. I'm going to say survived and perished. Getting all dramatic. So first class, I have all my numbers here already. I'm just going to use those. 62% of first class survived. So that's like basically right between these two. And so I'm going to say all y'all survived. Good job, you. In second class, 41% survived. So there's 50. So we're going to take it down a notch. So in second class, less than half survived. In third class, only 25% of folks survived. So that's right here. So here is our third class survival. And then crew, just slightly less than that at 23% survival. So once again, we can see that the distribution of survival is not even. Knowing what class someone was in could give you a decent idea of how likely they were to survive or not. Okay, I hope that's helpful. I will post these notes as a PDF as well as this video. Obviously, that's why I'm making it. Do your best with the problem sets. Write down your questions, and we'll get to them. Don't stress. You'll get this. Bye. Where are my buttons? Oh dear.